Hi guys, this is Math 116 and we're moving on to Chapter 4. So this is section 4.1 and this section is all about graphing linear inequalities. So I'm just going to jump right into it and give you a question. Let's look at this one. Question number 1. We have y is less than or equal to 2x minus 1 and they're telling us to graph it. So if this were a line, the first thing to do I like to think of is what is the line that represents this inequality? Well, the line would be y equals 2x minus 1. You'll notice this is less than or equal to, but let's start by looking at the line that's going to define our boundary. This is going to be like the fence for us. And for me, the easiest way to graph a line is to get 2 points. Once you have 2 points, you can draw a line between them. Right? So let x equals 0, because that's an easy point. That gives you y equals negative 1, because I just plugged x equal to 0 in there. 2 times 0 minus 1 is negative 1. All right, well, we need one other point, and I usually let y equals 0 be the other point because I'm lazy and that's often the easiest. So quickly, if you let y equals 0 here, you have 0 equals 2x minus 1, which implies that 2x equals 1 or x equals 1/2. I'm being a little systematic about this. Some of you might just see these 2 points right away. So I have a 1 point, which is 0, negative 1, and I have another point, which is 1/2 and 0. So I can now draw these, and for the purposes of your tests, this is the kind of graph I want. So it's going to be a nice, relatively straight line. Remember, this is the x-axis, this is the y-axis. 1 point is x equals 0, y equals negative 1, so just label it negative 1 like that. There's a dot there. And the other point is x equals 1/2. So here's maybe 1. We'll let that be 1/2. Just label it so I know what you're talking about. So that other point is x equals 1/2, y equals 0, like that. And now draw a line between them. Your line may or may not be, perfectly straight, but that'll work like that. Okay, so there's a line. I have only now graphed the line y equals 2x minus 1. I have not yet graphed this linear inequality. So when you see these inequalities, it's going to be a region, and they want you to shade it. So we want y less than this line. Every y that is less than this line. So here's what you graph, like that. You just shade it in. Like that. That's your answer. I'm going to show you what this looks like on a lovely graphing calculator, or graphing program on the computer. Y less than 2x minus 1. Ta-da! Same thing. So you'll notice this is less than, not less than or equal to. So less than would just mean you don't include the line itself. Technically for this one you should include the actual area of the line, but whatever. So on my picture, go back to my picture, which was not nearly as nice, but you can imagine for the purposes of a test, I accept this. Basically saying I want the less than side. This is the negative side of the line. If it had been y greater than or equal to this, you'd picked the other side of the line. Okay, let's do a more complicated one. Here is question number 17, jumping right to a complicated one. Suppose you have several of these equations. You have a system of inequalities, and you want to find the graph where they are all, find the region where they are all true. Oops, I picked the wrong one. Question number 17, ignore that, is you have these equations. X plus 5y is less than or equal to 200. And you have 2x plus 3y less than or equal to 134. And you want x greater than or equal to 0, y greater than or equal to 0. And there you're supposed to graph the solution. Okay? Graph the solution. So here's how you do these. You're going to graph each one separately and shade in the area where they are all true. So you're going to graph sort of separately, except they're all going to be on the same graph, and then shade where they overlap. So in order to graph each one, I'm going to do the same thing that I would do just to graph one of them. Let's start with this one. So we have x plus 5y is less than or equal to 200, and I want to write this in terms of y something. I want the line, the boundary line is going to be y equal to, bring the x on the other side, I'll do it this way, 5y, negative x plus 200. So I have y equal to negative 1/5 x plus 200 divided by 5, that's 40. So this is the first line. draw one line that looks like that. But we haven't, in order to draw this line, again, we need to find the points. So if I let x equals 0 for this line, I get the point, plug 0 in there. You get 40, right? That's a 0, it becomes 40. And then if you let y equals 0, some of you can just see this right away. You don't have to be so systematic about it. But this would be negative 1/5. What is the x when y is 0? Well, x is going to be 40 times 5. So, in this case, that is 200. Make it back to yellow. So you can graph your first line here. This first line right here has 2 points on it, 0 and 40, and then 200 and 0. Let me see if I have this one. Nope, I was going to graph a... Alright, I'll just do it here. It's going to be a little boring, but I'm just going to show you. Again, part of the reason I do this in sort of a lame way, so I'll say 50, 100, 150, 200, like that. I want to show you that sometimes when you're graphing these, they don't have to be all perfectly perfect. So our points, again, were 0 and 40, and then 200 and 0. So when x equals 0, I'll go, I'm trying to remember how high the other graph went. So I think it's like 50, 100, sometimes scaling these right away. So when x is 0, y equals 40. X is 0, y equals 40, about like that. And then when x is 200, y equals 0. 200, y equals 0. So you would have some line like this. Oops, whoa, I think I started out wrong. You see, I can't, gotta make sure I start here. Something like that. Except this line's gonna go on forever, right? Like that. This is probably the worst graph you've ever seen in your life. So, but you don't grade the papers I grade. Ha ha ha. Anyway, I'll make a better one on the graphing calculator in a second. So the point is we have one line here. I'm going to work on this next equation. 2x plus 3y is less than or equal to 134. So I have 2x plus 3y is less than or equal to 134. You're going to do the same thing and find the boundary for this one. So first we'd say, well, what would the line boundary be? That would be negative 2x plus 134, divide everything by 3, like that. Divided by 3, divided by 3. I get negative 2/3 x plus 44.66. That's not very satisfying. I like round perfect numbers, but that is in fact 134 divided by 3. So again, in order to graph this line, you want to find 2 points. If you have 2 points, you have a line. So we'll let x equals 0 as 1 point, just because it's easy. You can choose any point you like. So you could let 0 in here. And that makes y 44.66. And if you let y equal 0, you can do the same thing we did before, and you find, looking at my notes, for y equals 0, what is the x? What a mess. Okay, get it right. You have your x equal to 66.9. This is because you have 44.66 when y equals 0 times 3 divided by 2. So these are 2 points. You can put these points on and draw the line between them. Here's ultimately what you are doing. I'll show you. I have this all on this calculator. So here's the first line. I put it in here like this. Y equals negative 1/5 plus 40. And here's the second line. Y equals negative 2/3 x plus 44.6. So you have these two lines here. And in both of the inequalities, go back here, we want the region that's less than those. Less than both of those lines. So we want this region less than all of that, but subject also to the constraint that we want x greater than 0 and y greater than 0. So I put this graph on a nice paint picture so I could draw all over it. So right here, draw. I'll draw in red. This line right there, that is the line. This one represents x plus 5y less than or equal to 200. And this other line, yellow, represents the line, the second one, 2x plus 3y less than or equal to 134. So we want the area that is under this line and also under this line, but is also x greater than 0 and y greater than 0. So I'm going to get a bright blue thing and fill it in. We want x greater than 0, so we're going to have these boundaries. 1, 2, 3, 4. These boundaries all maintain the solution. And this is our answer. When they say graph it and find the solution, this is how you're graphing it. You're drawing the two lines and then you're shading in the region that matches the requirements. So in this case, this region looks a little bit like a triangle thing. And sometimes this book talks about the corners. So what are the corners of this region? Well, one corner is right here. That's 40, x is 40, or excuse me, x is 0, y is 40. Another corner is here, right there, 9.86 and 38.03. Where did that number come from? I'll show you in a minute. What? It's the intersection of the two lines. And then down here, the intersection 66.9 and y equals 0. And then there's another corner down here, 0, 0. So there's 1, 2, 3, 4 corners. And the answer looks like this. You're probably thinking, my answer is going to look a lot prettier than that. And the book's answer is probably much prettier than that. But again, you're thinking, I want the region, if I go back to my graph here, I want y less than this. See how it shades that area? And I want y less than this. And they overlap. You're looking for the overlapping of the area. And it overlaps from here to there, there to there. So imagine if you wanted two layers, that's where they overlap. And you want x greater than 0. If you want, I can maybe write that there. And then down here, it's really easy if you have this nice graphing program, isn't it? We also want y greater than 0. So if you have this fancy graphing app, except it gets kind of muddy, you want the area that where all of them overlap. I don't like these last two. So anyway, that's from here to here to here to there. Boy, this sure got ugly. Okay, I don't like having those last little ones on there. They kind of mess it up. So one last thing. Suppose you wanted to find this spot right here, that corner where they intersect. Obviously, I just clicked on the point and it said, 9.86 and 38.03, which is totally handy if you have a computer and you're clicking on it. But you will not have a computer to click on when you are taking the test. So this is how you would solve them. You would say, I want the two graphs to be equal to each other. And the first one was y equals minus 1/5 x plus 40. And we want that to be equal to the next one, which was negative 2/3 x plus 44.6. You set the y's equal to each other. And then you solve for x. And when you do this, you should get something like x equals 9.86. It's kind of a mess, but on one side you end up with 2/3 minus 1/5 times x equals 4.6, like that, and you just divide. So that's your x, and then you can plug it back into either one of these equations to get your y. If you plug the x value of 9.86 into there, you should get a y of 38.028. So to quickly review, when you have this system of equations, you want to take the first one and write it as a line, and then find the 2 points on the line and graph that line. Take the second one, write it the same way. You want to write the equation in terms of y equals something, like this. Y equals, write it, rewrite it. Graph, find 2 points and graph that line, and then you want to look for the region where the two lines overlap. And again, because it's less than, I'm shading in the less than side. So this one's all about drawing lines and then looking for the places where the shaded regions overlap. So look that over and let me know if you have questions.